Hi guys, welcome to my YouTube channel. In today's video, I'm going to be solving a question on mathematical induction. We have to prove by induction r divided by 2 to the power of r from 1 to n equals to 2 minus n plus 2 divided by 2 to the power of n. So our first step is to test n equals to 1. So anywhere we see n, we are going to put 1. And anywhere we see r, we are going to put 1. N equals to 1. Now we have 1 divided by 2, 1 equals to 2 minus 1 plus 2 divided by 2, 1. So we have 1 over 2 equals to 2 minus 3 divided by 2. 1 over 2, 1 over 2. It means n equals to 1. Now let's test n equals to 2 as well. So if n equals to 2, the sequence will be, the first one is 1 over 2. So the second one is 2 divided by 2 to the power of 2. So it's 1 over 2 plus 2 to the power of 2 to the power of 2 equals to 2 minus 2 plus 2 divided by 2 raised to the power 2. Now we have 1 over 2 plus 2 divided by 4. 2 divided by 4 equals to 2 minus 2 plus 2 is 4. 2 to the power of 2 is 4 as well. So 4 divided by 4. We have 2 here, 1, 2 here, 2. That's half plus half is 1 equals to 2 minus 1 as well is 1. So the second is what? 1. So n equals to 2 as well. Now our sequence will be 1 plus 1 over 2. 1 over 2 plus 1 equals to 2 minus n plus 2 divided by 2 to the power of n. R divided by 2 to the power of r equals to 2 minus n plus 2 divided by 2 to the power of n. Summation n r plus 2. Now our next step is to assume n equals to k. Now we are assuming n equals to k. It means anywhere we see n, we are going to put k. So we have summation k equals to 1. We have 1 over 2 plus 1. Then we have k divided by 2 to the power of k equals to 2 minus k plus 2 divided by 2k. Our step 3 is to assume n equals to k plus 1. So anywhere we see k or anywhere we see n, you can just put k plus 1. So k plus 1, 1 over 2 plus 1, k divided by 2 to the power of k, then k plus 1 divided by 2 to the power of k plus 1. Now this one is like this because k comes before k plus 1. So it's k first before we have k plus 1. Then it will be equals to 2 minus k plus 1 plus 2 divided by 2 to the power of k. Now the next step is to substitute this one into this because this one is also the same thing as this. So and it is equals to 2 minus k plus 2 divided by 2 to 2 raised to the power k. So anywhere we see something like this, let's substitute it into this. It will be 2 minus k plus 2 divided by 2 to the power of k plus k plus 1 divided by 2 to the power of k plus 1 be equals to 2 minus, that's now we are here, we have 1 plus 1, that's 1 plus 2, that's 3. It's also saying that k plus 3 divided by 2 to the power of what? K plus 1. Now let's simplify this. Now this we can use this one. So the LCM, let's bring this one together. the LCM of this is 2 to the power of k plus 1. Now 2 to the power of k plus 1 is also the same thing as 2k multiplied using the law of indices. 2 to the power of k multiplied by 2. So it means 2 to the power of k plus 1 divided by this will give us 2 divided by 2k. So 2k will cancel 2k. This means 2. So that's 2 minus 2, because there is minus here. Minus 2 bracket k plus 2 plus k plus 1. 2 to the power of k plus 1 divided by 2 to the power of this 1. So multiplied by this will give us k plus 1. We have 2. We still have 2 here. 2 minus 2 times minus 2k is minus 2k. Minus 2 times minus 2 is minus 4 plus k plus 1 divided by 2 to the power of k plus 1. So we have 2 minus 2k minus 2k minus plus k is minus k minus k minus 4 plus 1 is minus 3 divided by 2k plus 1. Now the next one is we have minus here, where we can bring our minus out. So we can, it will now be 2 minus bracket k plus 2, which is over 2k plus 1. Now we can see that is equals to 2 minus k plus 3 divided by 2k plus 1.